Yes, so I'm going to go ahead and introduce our first guest speaker this evening, and that's going to be Daniel Strübig. And Daniel is an R&D engineer at Jabra in Copenhagen. He's originally from Germany, and tonight he's going to be speaking about audio quality prediction, if I remember correctly. And that's going to be a Rust-flavored introduction. So I'm really excited to know exactly what that's going to entail. And I think we're going to split the talk into, is that right? We're going to have some of the talk and then some questions and then the second half.
Yeah, that would be the preferred way for me. I think it's best for everyone instead of me cramming up the whole content into one bit, and then all of a sudden we have to start answering questions that were answered half an hour ago or something. That's something I would not prefer to do. Is it okay if I just start sharing my screen, or anything else you want
Whenever
to say?
you're ready.
Cool, perfect.
Go ahead. Thank you.
Okay, so let's hope this all works out. So yeah, thanks Rachel, thanks Josh, thanks Jatin, everyone for organizing, and everyone in the chat or on YouTube sort of attending this or watching it afterwards. So yeah, my presentation is sort of like one of my attempts to work on my New Year's resolution for 2022 and sort of start presenting a bit more of the stuff that I've been doing sort of in my spare time, and actually getting it out there and sort of start sharing information and maybe inspire other people to see what they've come up with given the information I provide. So the topic I'll be talking about is sort of speech quality metrics. You could replace the word speech with audio, but I find that they're very difficult to get out of my system simply because I work with speech signals basically every single day. So if you ever hear me say speech quality prediction, evaluation, or metric, they all sort of mean the same thing. And then the second part, I will sort of get a bit into the Rust flavored bit and just sort of share some lessons that help me sort of pick up a new, rather complex language, basically while having a day job, something that's can be challenging at times. And I just hope that inspires some of you to learn and to grow as developers. So Rachel introduced me previously, but I would just like to sort of repeat who I am. My name is Daniel. I grew up in Germany. I've been living in Copenhagen, Denmark for a little over 4 years now. I currently work as an R&D audio engineer at Jabra in Copenhagen in Denmark. So very much involved in sort of research and development for anything DSP related. Specifically, I work in a small team that works on speech enhancement, so things like noise reduction, voice detection. I have a fair bit of experience with deep learning in that space, and also sort of speech evaluation and speech quality. Speech quality in general. On the right, you can see me standing at Aachen Museum outside of Copenhagen, pretending that I understand art. I'm a frequent ADC participant, so if you're somewhere in the audience and you find me sort of vaguely familiar but can't really put me in a context, I've been a very frequent audio developer conference ADC participant. I've also been the guy who's been working on Soul tutorials in the years 2020 and 2021. So if you've seen these videos, then that's really cool for me to know. It's a great time working on these videos. Previously, I had a career in location sound, film and game audio design, and also the bits of game audio programming. I have a degree of Masters of Science in Sound and Music Computing from Aalborg University in Copenhagen. It's an education that basically focuses on DSP development, the underlying math and the software development aspect of things for these applications. Before I venture into the whole topic, I would just like to give an overview of what Jabra is as a whole, because sometimes people cannot really locate the name of the brand. So just to give you an overview of what I'm sort of concerned with. Yeah, the company that I work in, sort of in my day-to-day life. So Jabra itself is a brand that focuses on sort of business headsets, speakerphones for meeting rooms, sort of meeting room video and audio solutions. Jabra itself belongs to a bigger corporation within Denmark called GN. And GN is a big sort of roof corporation for many other brands, and that is actually a very interesting field to work in. So there are basically three pillars here. The sort of medical side of things. So there are many medical brands which produce headsets for hearing aids for hearing impaired people. So who work on technology for that. Then there's also the space I've just talked about, which is mainly Jabra, which focuses on sort of enterprise solutions. Jabra also has a strong position in the true wireless market. So anything like miniature earbuds that you use on your daily commute to and from work, for sort of canceling outside noise and listening to your favorite podcast. These are also products that Jabra produce and that I'm personally heavily involved with in developing. And lastly, there's also a company called SteelSeries, which is producing sort of gaming headphones, earbuds, speakers, and also things like keyboards and mice. So it's a very sort of colorful bouquet of audio brands under that roof, and it's so far it's been leading to very fruitful collaborations to have sort of various fields of expertise under one roof. It's really nice. It might be a bit different. I think usually on Josh's channel there are it's a lot more about sort of DSP sort of plugin development, and also sort of user interface development. So here everything is it's a bit of a different domain, but the paradigms are definitely similar that we work with in our day-to-day jobs. So without further ado, I'm going to talk about speech quality metrics, a very term that doesn't sort of roll easily off the tongue, but I'll try to explain it sort of as beginner friendly as possible and sort of try to eliminate all the expertise and all of the implied knowledge that I have and simply say, okay, how would it work? How could I explain this the best way possible if somebody without the knowledge that I possess, were to learn about these things. So I'm just going to start off with an example that as an audio developer you are hopefully familiar with. So let's assume you have the following situation at hand. You have some input signal. It could be single channel, it could be multi-channel. We can disregard that for now. And you run that through some type of processing step. So what you end up is with some type of output signal. Again, mostly mono-channel. Could be multi-channel. But this output signal is what we are going to concentrate on for the remainder of this presentation. And it's really about the qualities and the features that make up this output signal. So here I've listed in this processing step, I've listed a couple of things that could happen, that I'm personally very much concerned with, and everyone else who works in the sort of communication industry and on that type of signal processing is heavily involved with. So it could be any type of data compression. You could be working on a communication client, such as the one we're using right now, such as Zoom. Could also be Microsoft Teams or WebEx or any other communication client here. You could be applying some noise reduction, so you end up with a potentially enhanced signal in the sense that you've reduced noise that you didn't want to pass through. But at the same time, it could be that you've degraded the speech signal along the way, because in the end, these are things that are difficult to separate overall. It could also be that you work on a codec or something else. For any types of speakerphones, you would need something like an echo canceller if you have a microphone that's sitting right next to a loudspeaker. Oftentimes you cannot simply get away with it, but you need to make sure that there's very little from the loudspeaker leaking into the microphone. So let's assume that you have this step. So you have an input signal, you have a processing step, and you have an output signal. And you want to assess the qualities of that output signal. So that's the situation that we're dealing with, basically. And you want to know, question you want to answer is sort of how faithful is my output signal? So this guy right here, how faithful is that to either my input signal, if you want to sort of preserve as many qualities as you possibly can, or, and I hope that is easy to wrap your head around, some known signal that you sort of desire to achieve. So it could be some enhanced version of a signal that is known, that is known to you. One example could be if you have a recording of a speech signal without any noise, and you run a noisy signal through this processing step, how faithful are you to your original speech signal? So that could be one of the use cases. And then the other question you want to ask is sort of how would another person, or a set of persons, the aggregate over multiple opinions, rate the quality of my outputs? And that is, I hope that this becomes clear, is that we are mainly dealing with sort of qualitative measures, either the terms of distortion or the terms of sort of bandwidth limiting you've introduced in the processing step right here. So these are the questions that we basically want to answer, and I hope that is somewhat clear. So what are your options, right? I mean, since we're all audio developers, that's we can of course start listening, and I would say yes, this is your pair of ears is the most valuable tool that you have in your at your disposal, and it's a crucial and it's a valid step, and you could probably go ahead and sort of rate that on a scale. Here I've introduced a scale from 1 to 5, so 1 being extremely bad and 5 being the best you could possibly imagine of your output signal having the quality that it needs. But you could probably argue that you would want more than one opinion, and also that the opinion that you get should be somewhat statistically valid. I'm not going to go into the whole sort of statistical analysis of things, but what you could do, and what is also very essential and crucial thing to do, is you could conduct a subjective study. So you simply start asking people, scale from 1 to 10. Sorry, on a scale from 1 to 5, how would you rate the quality of my output signal? But these things, they are, in my personal opinion, they are well, maybe not expensive to make, but they at least they take a lot of time to make. Subjective studies are very difficult to get right and to really nail it. You would need to remove as many variables as you can from your listening test. And lastly, they simply take a long time to conduct, to analyze, and to also conclude the results. And oftentimes in early stages of algorithm development, that you might be more to sort of leaning towards the side of how can I get opinions quickly, or how can I get an assessment of quality quickly. So let's park all of these things to the side for now, and let's say, okay, we want to have something fast that is not your own opinion, but would simply sort of approximate the average listener, and an assessment of that. So we can keep some definitions, and we are going to define what we otherwise known as a MOS scale. So MOS stands for mean opinion score. So it's basically the sort of the average rating of an average listener to a degraded signal, and we can define that scale from 1.0, which is extremely bad, to 5.0, which is extremely excellent. Best of all worlds. Thank you very much. And then the output signals of our algorithm are rated on this scale from 1 to 5. And just to make things a bit easier for us, we can safely assume that a difference of 0.1 on that scale is just noticeable. So if you have two signals, one is rated 2.2 and the other one is rated 2.3, the average listener would be able to discern these two signals and say that there is a noticeable, albeit just noticeable, difference between these two signals. It's all very researchy, it's all very nerdy and very academic, but I hope you can sort of bear with me here, and maybe in a minute start seeing all of these, like the beauty that's underlying in this machinery. So basically, what we need is a machine that, given a process signal or output signal, and a known desired signal, it computes a score on the scale that we've defined earlier, with 1.0 being extremely bad, 5.0 being the best you could possibly achieve. So we have these two signals, and then we have this I've called a speech quality predictor right here. And this speech quality predictor will simply take all of these signals and tell us what is, on a scale from 1 to 5, how would an average listener possibly rate this? And I hope that this makes sense. And if this known desired signal is a bit unclear to you for now, I will explain it in a second from now. So in essence, this is what audio quality predictors do. You have two signals. One is the signal that you want to achieve. The other one is that you can produce right now with the algorithms that you have at your disposal. And these quality predictors, they simply take these two signals and say, okay, we have some assumptions about the average listener and how that average listener would rate that. And we are simply going to output a score. So I would like to demonstrate that with an example of one of these quality predictors. One of these is called Viscal, developed by Google. And just for completion here, there's a multitude of these metrics out there, with potentially of various amounts of use cases, and specialized and trained towards sort of different degradations and different types of signals. So the audio file that I will play back is basically a person saying, "The birch canoe slid on the smooth planks." Don't ask me why. I don't know to which degree that person is into canoeing or into smooth planks. I really don't know, but it's a sentence from a very canonical set of sentences that were developed many years ago, which in combination are what's called phonetically balanced. So all phonemes of the English language are sort of represented equally. It's a very nerdy way of thinking about languages, but let's stick to that for now. So I will switch off my my keynote right here, and I will switch to Audacity. Josh, we made it work before we started the live stream, so hopefully this is all gonna go well.
My fingers are crossed.
Yeah, mine too. But let's look at two different signals here, and these signals I've taken them from from a test set of the speech quality predictor right here, which is which was developed by Google. So let's take this reference signal right here, and I will start playing that 2 times. And I would just like you to like everyone to sort of memorize what are this what are the key features of this. So I will just start playing this back 2 times, and I'll also shut my mouth.
The birch canoe slid on the smooth planks.
Did everyone hear everything? Did it go through, Josh?
Yes.
Okay, I'll play 2 more times. Okay,
The birch canoe slid on the smooth planks.
and I'll play it 1 last time.
The birch canoe slid on the smooth planks.
So this is one of I would argue female talker. I would assume female talker saying this sentence right here. Well, we can then, if we take that as our golden reference and we say, okay, this is the best we could possibly achieve, but in order for an algorithm or a solution to work, we need to compress the signal, not in terms of loudness or volume, but simply in terms of information. We need to reduce the amount of information that's in there. And let's say we do this, we come up with something clever. Oh, as the people at Google did, they came up with something clever. And then we run this through our processing step, and we end up with a degraded signal. So I'm going to play this 2 times again, and then I will play the reference signal 2 times again, and then I will play the degraded signal 2 times again. Okay, just so you can understand some of the key difference between the reference signal and this degraded signal right here.
The birch canoe slid on the smooth planks.
And I'll play it again.
The birch canoe slid on the smooth planks.
And I will play the reference signal again.
The birch canoe slid on the smooth planks.
And again.
The birch canoe slid on the smooth planks.
And then finally, I'll play the degraded signal again.
The birch canoe slid on the smooth planks. The birch canoe slid on the smooth planks.
So there are some subtle differences. And I hope this all, that the processing that was introduced by Teams while we're on this call hasn't been diluting the differences too much. But you could possibly hear that, especially the sort of S sounds, and also some of the vowels, they tend to be a bit distorted or a bit sort of filtered, if you will. And just to illustrate this, I will just switch both of these signals to spectrogram view. So basically, you still have a timeline on the x-axis, and then the y-axis basically represents the frequency bins that we are concerning with, and then the color or the intensity of each of these lanes, if you will. They represent how much energy there is in a certain frequency bin. And if I also switch the degraded signal to a spectrogram view, then you can see that basically most of the information in the high frequencies, sort of above 4 kilohertz, is completely gone. So we can see that there is a significant degradation, and if you were able to hear that, then kudos to you. Great job. So that's what we can do, right? And now we want to see, okay, given this is the output signal we produce, how would an average listener sort of rate that from 1 to 5? And what you can do right here, oops, I should have probably cleared my command line, giving away too much, is we can simply start launching this out. Now it's called Visco, what the RS stands for, we'll get to in a second. But usually these come as sort of command line executables, many of these algorithms. And what we can do is we can start giving it some command line flags. If you're not too familiar with the command line, I'm sorry if I'm losing you here, but yeah, that's I think you might be able to read up on what these commands actually and how a command line works afterwards. So we give it a flag called reference file, and this is just a path to the reference signal that I've showed you earlier. And then we also give it a degraded file and a path to that degraded file right here. And what we basically get is we have an input of two audio signals, one desired one and one that we can currently achieve. And we basically get a single number out in the end. And I will also use speech mode flag right here, basically to tell the algorithm to tell the predictor that this is a speech signal we're dealing with. And if I hit enter, it's going to take a small while. And after some other text right here, we actually get this MOS that I've presented earlier. And we get one of 2.3994454, whatever, 2.4. So we are roughly halfway where we could potentially be. And this just goes to illustrate sort of how these speech quality metrics work. And I hope that you I haven't lost you yet. But so this is what audio quality predictors do, and we've just looked at an example of speech which has been band limited after some processing step, and this is what they do. So the other thing, and then this sort of reference signal comes into play. There are going to be some more definitions that I would just like to add for completion. Is that the known desired signal, so what you want to achieve, is usually called a reference signal. Reference signifying, that sort of an upper bound that you could possibly imagine to achieve with a certain processing step. And then there are metrics which require a reference signal, and these are called intrusive metrics. So intrusive meaning we need to have some insight of what's the best possible thing we can achieve, right? It's basically, how can I put this the best way? It needs to have a certain, these predictors, they need to have a certain a certain sense of information of what is the optimum that we could possibly achieve in order to maximize the full potential of this scale from 1 to 5. Otherwise, you would start, it would basically clamp at 1.0. It would start clamping at 5.0, and that is not really insightful. But there are also metrics which do not require a reference signal, and these are called non-intrusive metrics. So they basically have an innate sense, sort of a inbred sense of knowing what good and what bad is, and they do not require sort of an upper reference right here. And also, lastly, just to drive this home, is that most, if not all, predictors work on a full audio file and not on a single block that you could fetch from your audio card or from your audio device. Because usually these things they sort of integrate over time, and all of these evaluators they look at a longer audio signal that's longer than a single block of data that you could fetch from your sound card. So it's full audio signal in and then a single number basically out. So that's that. There's an overview. I've provided you here with an overview of what's out there basically. This is of course an incomplete overview because I'm not aware of anything and everything that's going on in this field of research. But there are things like Polka, Pesk, 3Quest. You might be starting to realize that there's a Q in all of these abbreviations, and this signifies some sort of quality. So every one of these metrics is looking for some type of quality in a signal. Viscal is the one I've demonstrated, and I'll talk about later as well. There's a metric called STOI, which focuses solely on the sort of intelligibility aspect of speech. There are many aspects to speech, and sort of looking at it from different angles. And intelligibility is only one of the many dimensionalities of that. There are things like ambiqual, which look at sort of I think by binaural signals and their qualities. And then lastly, there's this differentiation I've made between intrusive metrics and non-intrusive metrics. So DNS-MOS developed by Microsoft, by Russ Kotler, and many other of the researchers at Microsoft, which basically made a model, a deep learning model, which sort of has this innate sense of what a good audiophile and what a bad audiophile is. And there's also Niska from people at the University of Berlin in Germany, which can achieve similar things. So there's a whole, a whole plethora of metrics out there that could potentially help you with achieving what you need to achieve in any type of communication product or other solution or software. So you might be wondering by now, what you could use it for. And I've listed a couple of sort of use cases right here. So there are things like regression testing, where you sort of have multiple versions of an algorithm, and you want to see sort of how they evolve over time, how you can whether or not there is an actual improvement. That I mean, your ear is one source of evaluating that, but these predictors could be a secondary one. You could potentially integrate it into your continuous integration or continuous development. Many of these predictors, they come as a command line executable or a web service. So it should be hopefully not too big of a pain to integrate them into CI or CD pipeline. And then what I've alluded to earlier, it's simply a good assessment during sort of the early stage development of an algorithm, and sort of validating a potential improvement. So is the improvement that you hear with your ears, is that reflected by a secondary pair of objective ears, if you will. And lastly, I mean, you tell me. Prefer this to be a dialogue, right? So if you would say that that there is a use case that I've overlooked or simply haven't come across just yet, then I'd be happy to engage in a dialogue and see what's out there. So how should you view these metrics, right? There's a certain sense of perspective that I would just like to provide here, and that is, of course, you can be. It might be easy to get complacent and to say, okay, this what the metric is saying is what the metric is saying, and that's the ground truth of everything. So these evaluators, these predictors, they I would definitely not consider them as the sort of the truth of whatever that means. And it definitely does not replace sort of thorough listening and training your ear. And I would actually argue that what I said earlier is that your pair of ears is the best tool in your arsenal that you have. But what I will say is that these evaluators, they are a good, I would say rather inexpensive perspective on how an output signal of let's say a codec or some type of data compression, how that output signal sounds to an unbiased and to an objective listener. I'm very much not free of sort of taking ownership and taking pride into the work that I do, but that also comes with a certain sense of bias that I might be things that I might be hearing things that I want to hear. And so putting these into perspective and sort of a grander scheme of things, it's a very healthy thing to do on a regular basis. These metrics, they are a very, very vibrant topic of research. And I would say that both the need for these metrics and also the sort of the emergence of deep learning neural networks have definitely helped in this topic of research. So definitely keep an eye out and choose these metrics wisely in case you ever attempt to introduce them to your tool chain or to your production chain. And lastly, which I find very, very just a very beautiful thought, is that it's a possibility to describe the quality of audio signals, which I find an otherwise pretty difficult thing to do. There we come up with a lot of terms like warmth, clarity, sort of, it could be boominess, or any other thing that you could think of to describe an audio signal, which I think is a difficult thing to do, because what does that really mean to every individual of us? So having something like these evaluators in your tool chain, they can definitely help shaping your perspective, and also help shaping your listening and your ear. For the avid listener, there's a very good sort of online discussion on the Danish Soundcluster.dk, which is an organization that sort of facilitates meetups for people in the audio industry in Denmark, which is surprisingly big. You wouldn't believe it for such a small country. But and this whole topic of perceptual audio evaluation is very, very vibrant, and it's definitely ongoing. And with that, I would just like to simply take a break, see where we are time-wise. Oops. And maybe take one or two questions in case there are any. If there's anything that's open for discussion. Josh.
So at the moment, we have one question from
Yeah, for sure.
from Paulo Chiliguano, who
Okay.
asks, "Is mean opinion score relevant?"
Mean opinion score. Yeah. I mean, yeah. I mean, in the end, it's up to you. I can personally tell you that these things are rather interesting for us as engineers. I think everyone in the field of communication industries that would definitely say that, yeah, they are important. They are not by no means crucial. I think in the end, a well-shaped ear and a sort of having an ear for detail and degradations, that's the determining factor. But it really helps getting a perspective on things. Yeah. And also I think the fact that it's been a very sort of emerging field in research. There must be a demand for these things. And the fact that there are many publications, especially in recent years, I would, from my point of view, yes, they are relevant. But you can feel free to disagree, of course. Yeah.
Great. We have another question from George,
Mm-hmm.
and this may go into what you're about to present here in a minute.
Okay. Yeah. For sure.
The question is, how easy is it to develop an audio quality metric? Does it take a research team, or can one person do this?
Yeah, it's if you want to develop your own metric, you mean, for your own use case, yeah, it's yeah, I would say it's a rather difficult thing to do. Most of these metrics, they have a lot of sort of nonlinear steps involved, such as a deep learning model. And I mean, the easy trap that you can fall into is that you can overfit to a certain set of input signals, and then if you give it something that it hasn't seen before, it will simply give you a random like a random score back. And these things I've said earlier how important they are in my day-to-day work, but ultimately it's a mixture of both your own listening and your own hearing, and what these metrics are telling you. And if you feel like there's a big sort of disconnection between these things, then you might want to evaluate this again. But long story short, I would say, yeah, it's not very easy to come up with these metrics, and they need to undergo very, very rigid evaluation.
Great. I think that's all the questions for now.
Cool. Yeah.
Please continue. We're
Can
curious
you,
to hear more.
can you follow, Josh? I hope it's not too deep down the gutter with the things that I'm doing.
No, I
Okay.
think it really, from my interpretation, it comes down to taking our interpretations of what we hear
Mhm.
as sound being better or worse, and posing the question, how do we develop algorithms that are able to do the same thing? Am I
Exactly.
right?
Yeah. Yeah.
Yeah.
That's essentially what's going on. Yeah. Cool. Great
Yeah.
validation. Okay. So that's the sort of first half. I hope I can speed things up ever so slightly. So let's continue and let's have a reset, and let's park everything we've learned earlier. And let's talk about Rust. And this is also the part of the talk where I will get a bit more sort of subjective and personal, and tell some personal stories that I've experienced throughout the course of this year. At the sort of the whole conundrum of speech quality and its evaluation is sort of a segue into that. I will also say that if you're learning, if you're completely new and you say, oh well, this is finally the moment where somebody will explain Rust to me in its great length and detail, then I'm sorry, I won't be showing too much code or too many examples. But this is rather a sort of subjective story, and I would also say there are many learning resources out there which do a tremendously better job than I could ever do in trying to teach you that language. But in case I'll try to get everyone on board here, and in case you're not familiar with Rust, that's a perfectly valid thing to do. But let me just get over some facts. So if we simply go to rustlang.org, then Rust itself is describes itself as a language empowering everyone to build reliable and efficient software. Rust stages itself as a general purpose language, and its main features, I would personally say, is that it's statically and very strongly typed, and a strong type system is a big ally when writing Rust. It has no interpreter. There are sort of intermediate representations, but there is no bytecode involved, and everything that you get after compilation is pure machine code, basically. One of the key differences that Rust has compared to other languages in similar sort of general purpose domain is that it does not rely on manual memory management, such as in C, or a garbage collector like C#. And instead, what Rust decided to do is that it enforces very strict rules at compilation time. It does that by utilizing a mechanism that was developed called the borrow checker, and with this paradigm of looking at what variable owns what, so looking at ownership, and also looking at how things are referenced, and in which way they are referenced. So either with read access or write access, otherwise known as mutably or immutably. It can basically enforce very strict rules at compilation time, which whenever you try to do some dodgy stuff or try to access memory that would be deallocated otherwise, it will simply say, I will not let you compile this. The compiler can look ahead in time and simply say, here are some suggestions for you, but right now what you're doing is dodgy. Please fix it. And it's a very good recommendation to play ball with this. And I, of course, don't mean that in a limiting way, but rather in a sort of in an empowering way. It also has an extensive tool system called Cargo for managing dependencies, generating documentation, sort of executing unit tests, sort of figuring out what functions are actually tests and which ones aren't. And so it's it focuses a lot on sort of developer ergonomics, and seems to do quite a quite a good job at achieving this. So if you talk about some hard facts, then usually some anecdotal truths are not far off. So I can again, I've mentioned that this talk will become a bit more subjective now. And I can personally tell you that while learning Rust, which I've been doing for a bit over 1.5 years now, is that I've started to, after a certain while, to start feeling a strong sense of accomplishment when writing Rust. The compiler, as strict and as no as it is, actually turns out to be your ally. It has some very strict rules on how you manage memory. But again, if you play ball, if you follow what it's recommending you to do, it starts nudging you in the right direction. And it's not so much about sort of limiting in the way that in the things that you can do, but rather you need to apply different paradigms of thinking and coming up with a solution that you've made. So in short, what I've started to sort of experience that when writing Rust is to put it personally, I can start to focus on the what, so actually implementing stuff, and the how, sort of how to design things. They sort of start falling into place, and they might not be necessarily optimal, but they will get the job done for you fairly well. After some practice, of course. There's no free lunch. But I can also tell you that learning Rust is definitely not easy. It's still a challenging thing to do. And that is just a good reminder, maybe for everyone. So saying that, just enforcing here that basically none of the stuff that we're doing is trivial, and it's probably the reason why many of us who work in this domain professionally have a master's degree, if not a PhD, and multiple years of academic experience. So this is far from trivial, anything that we're doing. Lastly, Rust is fast, and I would say that's what we need here. What I've implemented is not it is it is not bound to any sort of real-time constraints. I've sort of deliberately shied away from that. But it would get the job done for sure. And so computing such a score, such a mean opinion score, is it doesn't need to be real time, but it shouldn't be completely slow either. It shouldn't take forever. And just what I've referenced here is like one of these papers called Energy Efficiency Across Programming Languages, where a set of researchers, mainly from Portugal, sort of took a look at different languages and started looking at if we implement the same the same piece of instructions across different languages, how do they perform in terms of energy consumption, in terms of time it takes to complete, and also their memory consumption. And this is a very interesting paper to read, I would say, to choose what's in your arsenal, basically, to choose the tools that you need to choose. So how can we marry these two things? And this is again sort of a personal journey here. Is that how did I learn Rust? And so far, I think you may have recognized my enthusiasm for any type of speech quality evaluation. And this sort of I tend to look at these things a lot, both within work but also outside of work. And what I decided to do is, in order to tackle this task of learning Rust, is I simply looked at what's out there, and I rewrote one of these evaluators. So the specific one that I rewrote is called VSQL, which is an abbreviation for Virtual Speech Quality Objective Listener. Rolls easily off the tongue. And yeah, it's been developed by Google and the University College Dublin, in Dublin in Ireland. There are some great scientific papers on the whole development. If you just type in Google VSQL in your favorite search engine, then it will it will spit out a multitude of different papers which go into the depth of how the score is actually being computed. And yeah, also just to stress this, so this whole metric is something I personally didn't come up with myself. Like all of the iterations that went into the actual algorithm, that was mainly done by the people Jan Skoglund, Andrew Hines, and Michael Shinen. Hope I'm pronouncing that correctly. So I'd just like to say a special thank you to them, and also that the idea is not mine, but I've simply taken on the challenge of rewriting one of these in Rust. So what does it do, practically speaking? Well, what is it I actually did? Is I simply studied the C++ code base. I definitely have a fair bit of familiarity with C++. I took a look at the C++ code base and the conference papers I mentioned a minute ago. The C++ code base is fortunately it's of very, very good quality, and it's very well tested. It has a build system that doesn't make you pull your hair out on a Tuesday afternoon at 8 p.m. or something. But it's it compiles nicely. Like the tests are very, very transparent and very thorough. And the way I went about it is I studied the C++ code base, the conference papers, and I wrote the corresponding tests and the implementation in Rust. Simply translated it one by one, and sort of did a rinse and repeat until one test succeeds, and then the second test succeeds, and then as you keep chipping away, as you keep working, all of a sudden you find yourself that all of the end-to-end tests they also succeed, and that's what I basically achieved. To give you a bit of perspective on this timeline, this is something that I did entirely outside of my day job. I started in January of 2022, again as a sort of New Year's resolution, start early. And I wish I could give you a better approximation. I think I spent maybe 2 hours per day. So, if the sun was out, I didn't spend any time. If it was raining, I spent 3 or 4 times working on that project. And I had my first sort of successful integration test, or successful end-to-end test in June of 2022. And what I've been doing ever since is sort of cleaning up, documenting, and eliminating errors that basically previous Daniel has made. And it's this sort of very cathartic feeling of looking at code that you've written maybe only a couple of weeks or months ago, and then immediately looking at it and saying, "Oh, I wish I would have had all of the knowledge that I possess now." And that sort of iterative cycle, that's ultimately very cleansing, in my opinion, to do. So I've also basically demoed it earlier. I don't know if you can see this, but this is basically this Viscal sort of -rs is basically saying, okay, this is something I've done myself, and this is the sort of Rust implementation of things. And it's basically it does the exact same thing as the other executable does that was written in C++ years ago. And you might say that, oh well, that's not very innovative, Daniel. But I would just like to stress sort of why working that way helped me in becoming a better developer, and also sort of making things easier for me. So I would just like to sort of muse a bit about the beauty of simply rewriting stuff that already exists, simply in a different language, and simply for learning purposes, and with no sort of financial or other constraints in mind. So the beauty of rewriting a library that already exists is that it ideally the library that you take as a reference is something that exists already. Again, ideally, should be tested. Please write your tests. But what they do is, personally, what I can tell you is that oftentimes the tests that were already existing, they served as some type of validation step in the implementation that I've made, and basically gave me this sort of rope to cling on to during development. It's also the simple fact that the idea itself is already there. And I would definitely say that I am a creative person myself, and I can definitely find ways to solve problems creatively, or to make my own pieces of creation. But both coming up with an idea for what to write and learning a new language, that is something I would say is can get pretty difficult to do, because it starts becoming some type of chicken or the egg problem. If your idea is not well defined, which it might very well be, then picking up this language is also not becoming any easier. And again, Rust has a lot of complexity. And I would say that combining these two things, if you can pull that off, then I mean, you have all my due respect. But personally, I decided to choose a different gateway into the language. So probably the biggest insight that I got at the end of this project was sort of seeing how paradigms can be transferred from one language to another. And I would say that's been the biggest learning experience for me personally. It's a simple way that in the end, programming languages are a tool to solve a certain task. And if you look at things like how Rust achieves polymorphism using trait objects, or sort of how to basically look at a V table in runtime and see and knowing what the correct entry to choose is something that it just gives you a fresh perspective, both if you are a seasoned C++ developer and also if you're a seasoned Rust developer. It's a very good sort of way of sort of cross-pollinating your own knowledge, if that makes sense. To simply say, okay, so you have similar paradigms. How are they achieved in two different languages? I will end with some practical stuff, some of the libraries that helped me get started. So what you could see earlier is, of course, I wrote a sort of command line executable, and there are various different sort of problems to solve in this. So anything from argument passing to reading a wave file to performing an FFT, to handling errors. The libraries that were used in the C++ repository are this Upsile library by Google. I find it a very interesting library, but which solves many of these sort of argument passing and sort of defining relationships between arguments for a command line executable. The equivalent for that, the crate, that's the terminology in Rust for a library, is called CLAP, stands for command line argument passing. It's a very well used and well adapted library with great support, and takes a lot of headache away from you. There's Hound for wave file reading, which is something you pretty much always want to do. There are many very good, very performant FFT implementations. And then one of the many beauties of Rust, I would say, is that error handling is actually part of the sort of core and standard library. And I've talked about this very strong typing aspect of Rust earlier. And basically, you can encode all of your error handling as sort of custom errors that you define and that you raise throughout the logic of your application. So lastly, hopefully this concludes my talk. Yeah, probably. I would just like to sort of share some of the things that I've learned myself. Sometimes the hard way, sometimes for seeing it. And that is when you're trying to learn a new language, I would say try to sort of reduce uncertainties as much as you can during the course of your application. So I've deliberately chosen a command line executable to implement because they are I would say they are slightly more predictable than anything that involves a graphical user interface. They're of course less shiny, and it's not as easy to show off your command line executable to someone. But I think it's a very sort of forgiving gateway to learn a new language. Then I would also say embrace ugliness, or sort of embrace that things are work in progress and sort of ever evolving, and the pace by which you learn the language and all the various aspects of it. They also start to dictate how sophisticated your implementation will be, but simply embrace that it won't be perfect on the first try, and be forgiving to yourself. Also take baby steps, and what has helped me personally is to start writing down your achievement. So anything counts, really. It could be anything from today I learned how to implement the plus operator on a type in Rust, or it could be I learned how to write a unit test, or I learned about the macro system, I learned about how trade object works. So the smallest achievements, they matter. They add up. They add up for sure. And also do not be afraid of using libraries in the beginning. I very much deliberately made the decision to say, okay, I don't need to write everything from scratch here. And very much learning a language involves learning libraries and how they work, and studying these is a very good gateway to see how you could potentially improve your implementation. I also try to sort of reduce unnecessary complexity. Of course, unnecessary is very subjective here, but especially real-time systems. I can speak for myself here, but they are definitely a pain to get right. And there are many sources of error lurking pretty much anywhere in the sort of peripheral chain. So I deliberately said, okay, if I free myself from any sort of real-time constraints and simply start small, then that is definitely a better gateway into learning a language. Give yourself time is something I would recommend. And also lastly, abandoning a project, abandoning writing a solution is always an option, and it will definitely not eliminate what you've learned along the way. All of these things are uphill battles, and if you choose something that's where you feel interested in, or you are interested in, such as for me it was this whole speech quality, speech evaluation thing, and then by all means try it. And if you start losing interest, if you start losing time, then abandoning it or calling quits is always an option. And there are only things to gain in either of these decisions that you make. So yeah, that was my sort of my advice that I've just personally learned over completing this. Where are we with the slides? Yeah, that's about it. Thanks. If you want to get in touch, I think LinkedIn is the best thing that I mostly respond to. I've put my profile right here. But if you start just looking for my name, there aren't many other people with that name and in the domain that I work in. So I'd be happy to engage in a dialogue either about Rust or about this whole quality evaluation conundrum. It can also be a controversial topic for sure. Oops, those are played. It can be a controversial topic for sure. But I'm just happy to hear if there's anything you've learned from this talk. And with that, I think I'll stop sharing my screen now, and see if there are any other questions or any other feedback that you have, Josh or Jatin or Rachel.
Yes. So great talk, and thanks for sharing your experience about Rust. Really
Thank you.
interesting to hear your experience about porting a library to another language. And there are a couple of questions.
Oh, here we go.
George has asked if you happen to know if there's a Rust equivalent of the C++ Boost library.
Oh boy. No, but that's simply the fact that I've touched Boost, but I've never I've personally never used it in any sort of major production or anything. So it would be very difficult for me to even assess, what's in Boost that is not in the C++ standard library. Uh, I don't know. It depends on the problem that you're trying to solve. Sorry, that's the best answer I can give.
Okay.
Yeah.
Great. So Quacks BK said, great talk. One thing that you
Thank you.
implicitly endorsed is test-driven development, which is incredibly helpful in developing any application.
Yeah, thank you.
And George also says, I rate this talk 5.0. Excellent.
Cool. Wow. Well, that's definitely a meta joke right there. Kudos to you, George. I wish I would have come up with that.
So Quacks BK had a question of
Yeah.
what's your favorite Rust feature or improvement over C++? He is guessing, or she is guessing, the
Mm-hmm.
build/package system.
Um.
You feel?
Yeah. It's a very difficult question. I try to stay, I try to stay as sort of unpolitical as possible for this, and I know that there are also, entire sort of discussions about why one language is better than the other. I don't think there's a better or worse. It all depends on the things you're trying to solve, and essentially in the end it's a tool and it generates machine code and what. I can personally say that yeah, the package managing is great. It's sublime, especially compared to a code base that doesn't use CMake. I think CMake has come a very long way in sort of facilitating facilitating build processes, and sort of taking away all of this extra sort of headache that you need to go through sometimes. I think the biggest advantage of Rust is that it has very little sort of historical heritage, right? For C, sometimes C++, it even has to support the architecture that's on my grandma's first calculator or something. Or what do I know? Some really old sort of architectures, and that's something that Rust doesn't need to have. So it can be a bit more sort of it can be a bit more flexible in sort of sometimes dropping features or introducing new features without having this backwards compatibility. So that also makes it its disadvantage, right? It's still young, it's still new, but that's okay. That's something I can live with. And otherwise, the whole macro system, is it's sometimes it's complete magic, and the code it's generating for you, and all of the headache that it removes for you. I've alluded to this clap crate earlier, which does a lot of the command line passing and sort of generating all of the help output for you. The option and the result types are great for handling errors. It's completely exception free. The way you sort of the ergonomics of things, the fact that you can that you have access to sort of views into arrays. It's similar. I think C++ has a similar like an equivalent with it now for std view or something it's called, but where you can sort of take a glimpse into a range of an array, and you don't need to think about a raw pointer. Is a great. It just frees up so much of the mental the sort of the things that I need to think about, and I can focus on the what and not so much on the how. So it's a bit of an elaborate answer. That's fine.
That's great.
Yeah.
So it looks like that's it for questions. Thank you very much, Daniel. That was a great
Cool.
talk.
Yeah, thank you so much. Thanks for having me. It's been
Two for the price of one.
for sure.
Yeah.
Cool. With that, I'll start muting myself. Maybe we can take over to Jatin.
Yeah.
And otherwise, if you feel like getting in touch or something, just hit me up on LinkedIn. And yeah, sometimes I'm a bit slow at replying. Hope that's okay. Okay, I'll shut up now. Thank you, Josh.